Section 7.5 is on page 375, talks about initial value problems. Solve the given initial value problems using the method of Laplace transform. So, we are aware that if you look at our formula sheet, this is, by the way, on page, this is 382. So we are aware, if I apply the Laplace, I will get the Laplace applied on y double prime minus the Laplace applied on y prime minus twice the Laplace applied on y. And that should be 0. Now, if I look at the formula sheet, and I'm looking at the Laplace applied, and again, this is provided you could use that on your test, it's right there. So if I take the Laplace applied on the second derivative and the first derivative, let me just drag that with me. I lost track of where I was. Oh, 7.5. So let me shrink those because we're going to use them. Excuse me, on multiple problems. So if I put that right there and I come and say, well, all right, let's see. The Laplace applied, that's s squared times y minus s times y of 0. In this case, y of 0 is -2 minus y prime of 5. That's this piece. This piece has a minus in front of it. Make sure to use parentheses. The Laplace applied on the derivative, s times y minus y of 0. Y of 0 is a -2. Minus 2. The Laplace applied on y, of course, is capital Y. And the Laplace applied on 0 is 0 in this case. So we put all the y's together. We're looking at s squared y minus sy minus 2y plus 2s minus 5. This is a positive times a negative, minus 2 equals 0. If I factor a y out of this, I'll have s squared minus s minus 2, and it's no big secret, it's right there. That should always be the case. If I move those to the right, we're talking about a negative 2s, this is minus 7 plus 7. That's pretty much how it works. And if I look for y, y is going to equal negative 2s plus 7 divided by s squared minus s minus 2. That factors into s minus 2, s plus 1. So this is a over s minus 2 plus b over s plus 1. So negative 2s plus 7 must equal a into s plus 1 plus b into s minus 2. Let s equal negative 1. I'll get 9 equal negative 3b. That indicates that b is negative 3. And I would take s to equal 2. I'll get negative 4 plus 3 equal a times 3. So that means a is 1. So, pretty much, if I'm getting that y equal 1 over s minus 2 minus 3 over s plus 1, and I apply the inverse Laplace transform, I'm going to fix this. Just give me a minute. Okay, I just moved something so that this fits nicer. So, if I apply the inverse Laplace transform, I get the solution. What's the solution? The solution to this differential equation. And that is e to the 2t And by now that is by 3, I believe. No, not 3, 4. And in case you've forgotten, let me remind you really quick. That's by 4 right there. Minus 3e to the negative t, that's also by 4. And we are aware that I could have let y equal e to the rt, figure out the characteristic equation, r equal 2, r equal negative 1. The solution is y equals c1 e to the 2t plus c2 e to the negative 2t, like we did back in chapter 3, I believe. And then plugging in the initial value problems, we can get the solution. But here, instead of integrating, we're using the table, which is theoretically the intervals. So the same is going to apply, and that's really how this section works. And that's why Laplace is so preferred, because you could apply the Laplace on a problem, use the tables and not use calculus. You're using calculus by using the table, but that's like a shortcut. So s squared times capital Y. I'd like to call it f. That's how we used to do it. But this book calls it y because capital Y and small y, you might mix those. And again, remember, you're going to get all of those. Minus s times y of 0, so that's plus s. Minus y of 0, minus 7. Plus 6 times the derivative on y, that is s times f, minus y of 0, so plus 1, plus 5, and on y it's simply f. So I like f. I'm going to use y, just stick with the book, but that's what most books use. Now, you notice on the right, if I apply it on this, that's 12 divided by s minus 1. This is by 4. So if I get all the f's or the y's together, I'll get s squared f plus 6. I missed something there. Plus 6s f plus 5f, right? So that's those three. Plus s minus 7 plus 6 equal 12 divided by s minus 1. So if I factor an f out of this, again, hopefully I'm not confusing you. Most books use that. This author likes the capital Y, which is cool. That is 12 divided by s minus 1. So this is, when I move it to the right, minus s, and this is plus 1. So altogether, let me give that a bit of space. F is going to equal, and let's see what this is. If you really work this out, over s minus 1, that's 12. And you're going to multiply this by s, so that's negative s squared plus 1 plus 2s minus 1. So we're talking about negative s squared plus 2s plus 11 over s minus 1. And when I divide by this, and there's a 5 there, that will be s plus 1 times s plus 5. And now, if I say f, that is a, that is a over s minus 1 plus b over s plus 1 plus c over s plus 5. So we're saying negative s squared plus 2s plus 11 equal a into s plus 1 s plus 5 plus b into s minus 1 s plus 5 plus c times s minus 1 and s plus 1. So let s equal 1. Those guys, I'll get 2 equal a times 2 times 6. Actually, that s equal 1. Negative 1 plus 2 is 1 plus 11 is 12. So a is 1. And let s equal negative 1, I'll get negative 1 minus 2 plus 11 equal, that's a 0, b times negative 2 times 3, and that's a 0. So that is 11, that's 8 equal, let me see, negative 2, that's a 4. You get 8 equal negative 8b, so b is 1. B is negative 1. And similarly, you let s equal negative 5, and you will get negative 25 minus 10 plus 11 equals 0 plus 0 plus c times a negative 6 times negative 4. So this is 35 minus negative 24 equal 24c. So c is negative 1 as well. So here, so to save time from now on, I'm going to stop showing this work because we did that in the previous section. So bottom line is, now I gotta adjust again because I want it to look balanced. So here we go. One more time. So if I put that right there, that didn't work the way I want. Okay, let me fix that. So we're looking at f equaling 1 over s minus 1 minus 1 over s plus 1 minus 1 over s plus 5. And if we apply the inverse Laplace transform, I get the solution to be e to the t minus e to the negative t minus e to the negative 5t, and this is all by 4. And do you notice here what happened? Instead of finding the complementary solution and the particular solution and c1 e to the negative 5t, c2 e to the negative t, that's the homogeneous or complementary. The particular is going to be a times e to the st, and then you plug 0, y of 0, y prime to find c1, c2. We were able to get the entire solution, including the coefficients. So to save time, I'm going to stop doing that. I'm just going to go ahead and show you what that equals, and we go from there. So number 6, the same deal. If I apply the Laplace, this would be s squared. So let me move that down again so we can see it. And here we are. So again, s squared times y, or capital F, minus s times 2 minus 7 minus 4. Make sure to put the 4 in front of the whole thing. S times y minus y of 0, which is a 2, plus 5 capital Y equal 4 over s minus 1 and minus 3. This is by 4. Now you could just put that at the end. That's not an issue. You don't have to mark this part. That's by 4. So if I go ahead and get s squared y minus 4sy plus 5y, again, it should be right there. And minus 2s minus 7 plus 8 plus, oh, no pluses, that's it, equals 4 over s minus 3. So if I take y out of this, I'm looking at s squared minus 4s plus 5. And on the right hand side, I'm looking at 4 over s minus 3 plus 2s, that's a plus minus 1. So if I would go ahead and say y of s squared minus 4s plus 5 will equal over s minus 3, that's 4 plus 6s squared minus 1 minus, that's minus 7s plus 3. So altogether I get fy to equal 6s squared minus 7s plus 7 divided by s minus 3. And if I factor this, that would be, that doesn't factor. Just, yeah, that should be a 2. That doesn't factor. So I'll take s squared minus 4s, take half of them, number and square it. Right, this is the 5. I just complete the square. Y equal 2s squared minus 7s plus 7 divided by s minus 3 times s minus 2 squared plus 1. Now here you will say that's a over s minus 3 plus bs plus c over s squared minus 4s plus 5. I got a to be a 2, I got b to be 0, and c to be a 1. So altogether I'm getting 2 over s minus 3 plus 1 over s minus 2 squared plus 1. And now if I apply the inverse Laplace transform, I will get the solution to this differential equation, including the particular and the homogeneous with the initial conditions, to be 2e to the 3t, that's by 4, plus e to the 2t, shifted 2 units, that's a 2, times the sine of t, and that's by 7. And that gets me the full solution, including the coefficients, which was a problem on its own, if you remember. Number 8, we're almost there. Only half of the section you have to deal with this part. The other half, you just have to come up with the standard equation for s, and they assume you could do that. So again, good practice. If I apply that Laplace on a polynomial, this will be s squared y. That's a 0. That's good. So that disappears, and minus 3 plus 4y equal. Now the Laplace, the Laplace applied on this, that's 4 times, this is over s cubed, that's a 2 factorial, minus 4 over s squared plus 10 over s. So altogether I'm getting a y into s squared plus 4 to equal all over s cubed, that's 8, minus 4s plus 10s squared, right? Because you get a common denominator. So y is 10s squared minus 4s plus 8 divided by s cubed into s squared plus 4. So y equals, and it's going to be, this is going to be a over s plus b over s squared plus c over s cubed plus abc ds over s squared plus 4. And here also I got a to be a 2, b to be a negative 1, c to be a 2, and this is a 0, and I got this to be a 2. So I got y to equal 2 over s minus 1 over s squared plus 2 over s cubed plus 2 over plus 4 plus, I'm sorry, 2s, I got this to be 2, and I got this to be 4, plus 4, well, 4 is really 2 times 2 over s squared plus 4. And now if I apply the inverse Laplace transform on this, I'll get the solution to this differential equations. That will be 2 minus t plus, this is still t squared, plus twice cosine of 2t plus twice sine of 2t. Now this is by, let me check really quick. I think that's 1, 2, 3, and 1, 1, 2, 3. 1, 2, 3, 5, and 6. 1, 2, 3, 5, and 6. This is 1, 2, 3, 5, and 6. Oh, backwards. 5 is the sign, and okay, sure. There we go. And that's how these problems are really done. So we have one more of these types before we go on to the last part of this section. Continuing on, if I look at number 10, the same deal. If I apply the Laplace on this problem, I'm looking at s squared y 0 times s, that's really 0, no need to write that. Oh, again, I forgot to copy that down. So minus 5 minus 4y equal, this is going to be 4 over s squared, and that is by 4, minus 8 over s plus 2. So if I get those two together and factor a y out, that's s squared minus 4 equaling 4 over s squared minus 8 over s plus 2 plus 5. So I could say y equals, and let's see what this is. If I get a common denominator, that will be 4s plus 8 minus 8s squared plus 5s squared times s, 5s cubed, and 5s squared times 2 is 10s squared, and if you divide by this, that's, is that a minus 4? That was a minus 4. So this is going to be times s minus 2 s plus 2. So altogether, y is, and if I put this in order, that will be 5s cubed. Actually, I could put that here because I'm not going to show how it works. So let's see. Y is going to equal 5s cubed plus 2s squared plus 4s plus 8 over s squared times s plus 2 squared times s minus 2. Now, and I could say that is a over s plus b over s squared plus c over s cubed. Oops, there's no s cubed. C over s plus 2 plus d over s plus 2 squared plus e over s minus 2, and here this is a 0, this is a negative 1, this is a negative 1, this is a 2, and the last one is a 1. So I could say that y equal negative 1 over s squared minus 1 over s plus 2 plus 2 over s plus 2 squared plus 1 over s minus 2, and if I apply the inverse Laplace transform, I'll get the solution, both homogeneous and particular, to be negative t minus 2e to the negative 2t minus 2t e to the negative 2t plus e to the 2t. And if I do the labeling properly, which I have to do, this is by 2, this is by 4, this is by 9, and this is by 4. And there it is. That's pretty much it. Now, this is all they want here. And those problems, they just say find y of s. So find that part of the problem only. So, in this case, if I apply the Laplace transform on this problem, I'll get s squared y, that's a 0, good, no s, minus a negative 1 plus 1 plus 6y equal. If I apply the Laplace transform on, that's 2 factorial divided by s cubed minus 1 over s. This is 3, this is 1. So if I factor a y out, that is s squared plus 1 equaling, and if I get a common denominator here, that would be s squared 2 minus s squared is s cubed. And I would say y equal, yeah, I forgot a part. I forget the 1. So the 1 will be plus a minus, and if I get a common denominator, that will be s cubed. There, much easier. And y would equal negative s cubed minus s squared plus 2 divided by s cubed into s squared plus 1, and that's all they want. Find y of s, kind of like saying find the particular solution, do not evaluate the constants. That's kind of what this is doing. It's the point is a calculator can figure out the coefficients if you set them up, but for now let's just follow along, apply the Laplace transform on this, and that will be s squared y minus s times 1, which is s, minus 3 minus 2 times s times y minus the 1 minus y equal 1 over s minus 2 minus 1 over s plus 1. This is by 4 and 4. So here I'll get those together. I'm looking at s squared y minus 2sy minus y equaling 1 over s minus 2 minus 1 over s plus 1 plus s, and I have minus 3 plus 2 is minus 1. When you move to the other side, it becomes a plus 1. So now it's just a matter of getting a common denominator and proceeding. And here, if you multiply this by s squared minus s minus 2, that's s cubed minus s squared minus 2s plus s squared minus s minus 2, that will be s cubed minus s minus 2. So I could say y equal all over s plus 1 into s minus 2 into s plus 1 times s squared minus 2s minus 1. That will be an s cubed. And there are, I thought there was a square somewhere. Let me see. S squared. Let me see. If you multiply those, s squared minus s minus 1, okay. Those cancel out, minus 3. And if I made a mistake, you know how this goes. That's all you need. And one more to go. Again, we want to touch on all of these bases. And the reason they're not having me work this out is because it's the same as everything else. If these are 0, then this is a very quick, the initial conditions are 0 because this is simply s squared y, everything else zeros out. And t cubed, that will be 3 factorial divided by s to the 4th. This is by 3. So you could factor a y out, that will be s squared plus 3. 3 factorial is 6. And you could say y equals 6 over s to the 4th times s squared plus 3. And that's all. And that's pretty much it for this section.